Up next, another Kenwood receiver. This one's from the, I'm gonna say, the late 1970s. Little small, about 18 watts per channel amplifier. Wooden cabinet. This one here's got a problem with the radio. Let's check it out. Okay, this time we got an old Kenwood. This is a model KR4140. And I know nothing about it. So I haven't turned it on. We're going to power this thing up. Someone's got the volume cranked all the way up. That's a good one to start. Speakers are in the A position. I'm on my dim bulb tester. I see half the display is burned out. The lights are out on half of the display. In stereo mode, FM. I hear nothing. Just some clicks and stuff. Okay, since it hasn't gone boom, let's turn off the current limiting and give it full power. Well, that's one thing. On AM we're hearing some noise. Left and the right channel, so that's a good sign to start. At least the amplifier sounds like it's working, but it's not picking anything up on the radio whatsoever. Is that my plasma set that's doing that? There, okay. So it's picking up noise from my plasma set that was on, but nothing else. And nothing on FM. Okay, so we have a radio problem on this. Let's dive in and see what's going on with this one. Well, it's got a bit of stuff in it, doesn't it? So this one features what's called a complementary output. So it's 4 NPN transistors, 2SD155 are the outputs, and this unit is probably 15 watts per channel. I'm going to guess. Amplifier section, FM decoder, IF strip, tuner. I'll give it an FM antenna, namely my hand. And we have nothing. No signal whatsoever. See, even AM. Other than when my plasma was on and it was picking up interference. Nothing's happening. So likely our problem is on the IF board. So here we have a print. Schematic, whatever. Some people will call it a blueprint, which is essentially what it is. And if we look at the circuit, we can break this down into several different circuits. We know that the power amplifier is working. We know that the tone amp is probably working, and we know that the preamp is probably working because we did get noise when I was in AM mode. The common area for both AM and FM is this area right here. This board. This is the IF board, which is the one that's right back here. This is the IF board, and this is, I think, where our problem is going to be on this one. Because it is something that affects both AM and FM, first thing we're going to do is we're going to look to see whether this board is getting power. Now we know that it's partially working because when I was in AM mode, I was getting interference from my plasma as I tuned across the dial. So it's probably something in the preamp, in the input section here, which is passed on from, this is the tuner So we have our AM antenna and our oscillator, and we have our FM preamp and mixer. So we have an FET here, which is the FM preamp, and then this is the FM mixer, and we have an oscillator down here. Here's our tuning capacitor. FM oscillator right there. FM oscillator. Where's our AM oscillator on this one? AM oscillator might be over here. It's AM circuit. Our antenna is connected over here. I wish this print was bigger. It leaves a lot to be desired when it's microscopic. I mean, this would have been a bigger print, but someone's reduced it in size so that it all fits on one page. I've made some notations on the schematic here where I want to check first. I want to check first of all for B+. So we have a Q5 here. This is our B+ regulator for the radio circuit. If we trace it back, we'll find that it goes over here and supplies us with our B+, which is common for both the AM and the FM. So the first things first, let's make sure that we actually have B+ getting to the actual board itself. Because if our B+ is low, it's going to affect our reception. So I can see it's been amateur hour in this one. Someone's replaced the power cord. Nice job. I bet it's not even soldered down. Just some tape on there. You know, it's like, we'll just remedy that. What do you bet? It's not soldered. Guaranteed it's not. Oh, it actually is. Okay, it's only a minor bonehead move because somebody should have stuck heat shrink tubing on there. If nothing else, don't just stick tape on. Tape can come off. Throw some heat shrink tubing on it and shrink it down. Put a heat shrink tubing over both of them and then tape them together just to prevent the heat shrink tubing from ever coming loose. I mean, when they changed the cord on this, they should have actually taken it right back to the power, to the convenience outlets rather than just chop it off inside and splice it on. That's just being lazy. But you see that happening all the time. Okay, so I'm looking for the regulator. The regulator's right up here, screwed to the back chassis. Let's plug this unit in and we'll check the voltages. See what type of voltages I'm getting on the regulator to make sure that I've got the correct B+. So one probe goes to ground. Power on. 14 volts, 33 volts, 14 volts. So our regulator is working, as you can see. 14.9, 32, 14.4. So it looks like our regulator is working. Now one of the ways we can try to localize where our problem is here is to use a good old finger technique and just put our finger where we would like to see whether there's signal to the amplifier from it. In this case, this is the multiplexed output that goes into the decoder board. So we know that we have signal there. But you see, as I work my way back, I hear nothing. So somewhere in here, we've lost our signal. If I go to AM, we'll see where the AM signal is. Doesn't sound like anything's getting through on here at all, on AM. And of course there'll be nothing on this board because that's just the MPX board. If we want to see our switch voltage, here's our B+ going in for the AM side right there. This is the FM B+. It's got 0 volts on it now. If I switch it to FM, this one now has 14 volts. Okay, if I measure my IFN going into into one of the amplifiers, I'll show you guys the scope. But I can see my FM stations. This is my test transmitter here. I'll show you guys what I'm seeing on the scope when I rock the tuning dial back and forth. So this is the input to the IF. As you can see, as I tune the station up and down, we will see some stations come in. We should see a couple ones that are really quite strong. Those would be the, because I don't have an antenna on it, but those would be the ones that I'm transmitting locally. That's my other one on the other side of the house. The one in the workshop here is down at the bottom end of the dial, and there it is there. And if I go to one of these other stations, if I put my antenna near the antenna, it'll get stronger. As you can see there, I'm touching the antenna terminals, and that's just a local FM station. So we know that the IF is working, going into that transformer, and coming out of the transformer, it's also there. And from there, it goes into it goes into the IF amplifier IC, which is this one right here. Yet I see nothing coming out of it. Nothing coming out of this output, this IF amp, and getting into the next stage. I'll show you where I'm probing with my scope. So here is where we have our IF signal right here, and here. Input to the IF stage is there. Output from the transformer is there. Goes into the first IF amp, which is an IC, which is right in here. You can see one of the pins there to it. And it goes into the second IF, and there's nothing. The second IF has got nothing on it. So it's either the IC is gone or it's not getting its supply voltage. I'll show you guys on the schematic where we're looking. So this is where we're looking right here. We have our IF here going in to the IF transformer and coming out, and then it goes into this IC, and from this IC it goes out into these other two IF transformers, and there's nothing there. So maybe this IC has lost its supply voltage, or maybe this IC itself is shot. I say good luck finding one of those, but let's see if it's got its supply. So we measure our voltage. Pin 8 is the power. There's two of them here, right? No, that's the input to the amplifier. That's why it's humming. If I measure pin 8, 13.59 volts for both of these. So they both have power. I got signal going in. I got nothing coming out. We'll measure it on this side. So here's our scoped input to pin number 3, which is the input. That's the pin 3 is the input. Looking at my pin out for it. Yeah, that's the input. And when I move the tuning, you can see, if I get my hand in the antenna, right? That's stations that we're receiving, or that are going to the input. So signal's getting into the input, and if we go to the output, which is pin number 7, which is over here, this is pin number 7, and pin number 7's got nothing on it. Sure looks like that IC to me is the culprit, and it handles AM and FM IF circuits. That's the one there. Pin 7 and pin 1 should be outputs. That's pin 7, and this is pin 1, and it also has nothing on the scope. That's pin 1, nothing there. So I'm afraid this one's probably not worth fixing. The guy that owns it, I don't think wants to spend a lot of money on it. It's not a real super high-end unit. It's only like 16 watts per channel, so it's not something that someone's going to spend a lot of money to fix. And that IC itself is probably next to impossible to find these days. It's an what is it? It's an SL20575. SL20575, and actually is a NTE 703 linear integrated circuit RF IF amplifier. So this is our pin out for this one, and we have our signal going in here on pin 3. We have our power going in on pin number 8. We have nothing on the outputs, pin 1 and pin 7. So that IC is no good. The only thing I didn't check was the ground, but the ground is not going to be open. If the ground was open, then yeah, we could conceivably kill the IC. It's pretty simple to check that. All I gotta do is just put my meter on pin number 4. I have a bunch of those type of ICs, but mine are all just op amps, so I thought maybe I might have one, but no such luck. And no, there's 0 volts on the ground as expected, so there's our problem. IF amp is shot. And that's about as far as I'm taking this one, because again, this unit here is not worth fixing. For those just wondering, does it work as an amplifier? Yes. It's just the radio that doesn't work on it. The phono in probably works fine as well. For a low power amp with a complementary output. So, to someone who's just looking for an amplifier to play records through, like a turntable, or to plug a CD player in, this would still be functional, just the radio portions shot. But when we're talking obsolete components like this, even if you could find the part, I'm going to throw that out there because somebody's going to come along and say, oh, you can get this part so such and such a place, it's only $2 or it's only $5 or whatever, or only $10. Even at that, it's not worth fixing if it's available. Just because it's not just the cost of the part, it's the cost of the part, it's the cost of shipping, right? So once you start factoring all that stuff in, that $5 part turns into a $30 part by the time you get it shipped. Anyway, just leaving it at that. It's not economical to repair the radio section of this receiver. Anyway, thanks for watching. We'll catch you in the next one. Bye.